on time. So thank you, Nava, very much. And thanks to the organizing committee for a fantastic job you have done. We have been trying to bring Jibo. Some of you know the ordeal of being in Jibo through the customs. Yeah, people don't know what it is. Yeah, and we shipped one, but it was difficult. So I hand carry with me, and the custom officer looks at it and says, "What is that?" I said, "Well, it's a robot prototype. What does it do?" He dances, and then he looks at me and say, "All right, just go, just go." So it was much easier than what I thought. So let me talk. I've been in conversational technologies, and Nava gave a fantastic presentation of what conversational technology is for a few years. And I prepared this talk. I want to talk about myself, because it's always good to talk about yourself. So, but I decided to change a little bit, to change the gear. And I say, why don't we talk more about Jibo, about what it is to build a complex consumer system like this. And it is very, very complicated. But I still talk a little bit about myself. And I jump back in time to when I first fell in love with speech, falling in love with speech. And it was in 1981. Most of you were not even born. And in a beautiful place in Torino, northern Italy, where was a prestigious center. They built one of the first text-to-speech systems in Europe. And I was fascinated. When I was a student, I saw that in TV. I said, I want to work there. And I ended up working there in speech, and I fell in love with this technology that in which I spent most of my adult life. So who recognizes what this machine is? It must be very old to recognize this. So don't try to. PDP 1160. So this is a machine, and you remember, has a very little memory. RAM, addressable RAM was 16-bit addressable RAM. Today it's totally inconceivable. So we had to go through hoops to make a speech recognition work on this. And I built my first speech recognizer, actually my first dialogue system on a PDP 1160. You had to boot it there was a little keypad here. And our system manager knew the bootstrap program by heart. It was there every morning, keying numbers. And this is, you know what this was? It was an advancement of technology. It was a disk. It was of this size, 7 megabytes. 7 megabytes. Say, wow, 7 megabytes. Can you believe it? 7 megabytes. If you take a picture, it's 30 megabytes today, right? And we share this disk with 2 departments. So it was it. And this is MUSA. MUSA was the first text-to-speech. One of the first in the world, but of course in the US probably they built it a few years before us, but definitely one of the first in Europe. It was self-standing. It was not connected to any computer. It was called MUSA, multi-user speaking automaton. And it was the size of a refrigerator. It was actually huge, right, with a lot of boards. So today, text-to-speech is software. You don't even know where it is, right? And I'll play this, and you get a feel how computers talked back in 1980.
Buongiorno. Mettete temi presenti. Sono un calcolatore dell'Oxens di Torino, il centro studi e laboratori di telecomunicazioni.
You say this came out in a 45 RPM disc, plastic. You remember, some of you might remember the plastic disc. And it came in a magazine, in a very popular magazine. Before I joined SET, I said, wow, I really want to go and work there. It's fascinating. To me, I don't know if any of you understand Italian here. Someone understand Italian? Yeah, but it sounds to me like a drunk Italian with a pronunciation problem. That's what this sounded, right? So I was there, and I built, actually I built a dialogue system that was totally useless. It could do 2 things. It could do calculations. Yes, wow, that's calculation by voice. Yes, but only 1 digit. So you could say, how much is 7 plus 2? How much is 3 plus 9? That's it. And you could also ask, can you divide by 0? and they say, you cannot divide by 0. That was great, right? It was an exception. And the second thing was another useless thing was you could ask for the telephone number, the extension telephone number of one of the people in the department. There were 6 people. So, but it was amazing. You know, I did finite state machine for dialogue, template-based dynamic time warping, and so on. So I really enjoyed that. And I also ended up on public TV on a science show for 35 seconds. My mom watched for 3 months to see me for this 35 seconds. It was my 30 seconds of glory. Probably less than 30 seconds. I'm exaggerating, but probably 15 seconds. Yeah. So after a few years there, in 1988, I decided to go to the United States. Who doesn't want to go at least once to the United States, right? So, and I ended up in Bell Labs. And Nava, you recognize we were at the 5th floor, right? You know, I was getting inside from here, somewhere here. And
Disclosing our age, it's not fair.
No. Nava was in kindergarten. You a special program for very gifted children. Is that right, Nava? I said. So I call this the years of unfettered research. Larry Rabin, who was our boss, told me when he hired me, say, okay, now you can do whatever you want. Really? You can do whatever? It was totally inconceivable. Yes, you can do whatever. So how do you judge me if I'm doing a good job or not? Well, if you write papers, you write patents, you go to conferences, it means you're doing a good job. And that's fantastic. Unfortunately, it didn't last for a long time. Something that unfettered research does not exist anywhere anymore in the world. Nav and I catch that at the ending. So my life at Bell Labs was characterized by what we call the DARPA projects. And probably you the artist, yeah, we did the artist too with Julia. You did the artist with Julia. So that was there was a resource manager, but recognizing 1,000 words with a very well-defined grammar, read speech. People were asked to read utterances, and then we recognize them. When you read, it's different than spontaneous speech. Then there was ATIS, Air Travel Information System, and the vocabulary was not defined. It was open vocabulary. The grammar wasn't defined, open grammar. It was spontaneous speech. And spontaneous speech has a lot of idiosyncrasies. If you look at, if you listen to me now, I'm quite spontaneous. I make a lot of mistakes. I have a lot of hesitations. I make a lot of all this type of thing. So no one at the time knew how to understand. So this was an understanding task. You had to understand questions on flights. So people could say, show me all the flights going from Boston to San Francisco tomorrow with American Airlines, and I want to have lunch on board. And then you have to transform that into a SQL query and access a database. And we did it. And actually, we did it in a very different way than anyone else. We decided, since the term, if you are a hammer, every problem will look like a nail. So Esther Levin and I, you know probably Esther, she was from Technion, from Hi-Fi. She moved to the United States. Worked together very closely for many, many years. And we knew very well hidden Markov models. Say, they are so good. We should solve also the problem of speech understanding, which is more a symbolic problem. It's not like a continuous signal processing problem. And we did it so well that the AT&T Bell Lab system resulted in the DARPA the best. We actually won the contest. And then we decided, okay, we are doing so well. Why don't we move to the next level of the human conversational ability, which is dialogue. And dialogue is simply how to understand what someone says and plan for the next thing to do. Could be a prompt, could be something like that. And again, I say, many people do it with by hand or by using linguistic things. We are not linguists. We understand machine learning, and why don't we use something called Markov decision processes and reinforcement learning? It was, and we started doing that, and that became very, very, very interesting. And we could learn dialogue from two machines talking to each other for days and days. One was simulating the user, the other was simulating the system, and then we could learn the policy of the Markov decision process. That became something that other people picked up, and they called it, they moved it into something more sophisticated called POMDP. So it was cited by Professor Kraut before. And now it's a mainstream research, POMDP, partially observable Markov decision process. But we started with the Markov decision process because it was simpler, it was easier, and so. So it was my thing. You see this, so I will go now one by one on these numbers, no kidding. So these are the DARPA evaluation things, and you see that there are tasks that with a very high initial delivery task, this is error rate. Word error rate is a measure we use in speech recognition. The resource management, 1,000 words, started with a very high error rate, and after working, we got very low. And then say, oh, that's so easy. Let's do something more difficult. 5,000 words, again, back to high error rate and working. This is time, right? 1993, 1994, 1995. And then something very, very difficult, switchboard, people talking on the phone. Can you recognize that? Error rates close to 100%. And then people worked very hard, and then we got something like around 15, 20%, and so on. So this is a history until 2011 of the DARPA projects. And the DARPA projects shaped the modern speech recognition. Then I done a lot of research, and a friend of mine who just started a company, his name is Mike Phillips, some of you might know him, called me and said, well, I want to start a company doing speech for real things, not just going to conferences and writing paper. I want to do it for people who call on the phone, and instead of pushing 1, pushing 2, pushing 3, I wanted to say what they want. Like, I want to check the balance of my bank account. I want to transfer money. I want to buy something, and so on. So I joined him. For me, it was the first experience in a startup. And it was amazing. I really loved it. And I understood the huge difference between working in academia, working in research, and working in startup. And I love both. So all my life, I've been going a little bit on one, a little bit on the other, and coming back, and so on. So in a startup, it's a totally different thing. In a startup, there is a lot of adrenaline. You never sleep. You work 15 hours per day. You have to, you have deadlines and something like that. And it's a different type of work. So this is an example of what I really like. We call it the speech application life cycle. So in research, 1 or 2 researchers built a speech system, another system. In a commercial setting, there are many, many people. And it goes from designer. The concept of voice user interface designer was totally obscure to me before I joined SpeechWorks. And then usability testing, looping into speech science, and going back to the design again until the system came out perfectly. And that, that was for me the kindergarten of building real things. And Jibo now is hey? He heard me. Thank you, Jibo. Okay. And I'm applying all these things to Jibo. Okay. And then I had a little interview at IBM for a couple of years, IBM TJ Watson research. And then I went to another startup called SpeechCycle. Our office was actually here. This was one of the entrances to our building, and was in front of the ball. No, yeah, World Trade Center was a little bit 6 blocks north. This is close to Battery Park. And actually, I was there for September 11th. I was in the office here. So in the previous company, not this one. So we built very complex data systems. I can play. These are systems for helping people who are subscribers of cable companies like Charter, Time Warner Cable. We're having TV, internet, something goes wrong, instead of talking to an operator, they talk to one of our system. And these are examples of...
Briefly tell me what you're calling about today. For example, I need to make a payment. Or you can say...
How do you increase the volume?
Choices. Internet. That was internet service, right?
Correct.
Which one can I help you with? Your bill, tech support, orders, it's starting to sound like there might be a problem with the input source.
That's right. Okay. They're annoying anyway. So this is what you find on the phone and terrible. I used to go to parties like everyone does. I say, what is your job? But I did this system on the telephone instead of talking to an operator. People say, that's horrible. And people didn't want to talk to me. So I changed after a while. I say, what do you do for a living? I'm in artificial intelligence. And people love that, right? So and then from Lifecycle, I became the director and the CEO of something in Berkeley called the International Computer Science Institute. A couple of years working back in academia with that, but I felt that I needed some adrenaline again. And then in 2014, I joined this small company, 6 people, 4 of them in Boston, 2 of them of which I was one, in San Francisco. And then I hired another person. We had 3 in San Francisco. There are a couple of people in Boston. And the first office in San Francisco was in the loft where my wife and I used to live. And we built the first prototype of Jibo there. And there was a collective work with soldering iron, putting things together. You know, for instance, for a few of you are roboticists. I'm not a roboticist. But I learned a lot about robots working at Jibo. The first thing that they do, roboticists, some of them, they put all the components on a board, on a wooden board, and they nail the components there to test all the things. And they call it the rod kill. You know what rod kill is? When you drive on a highway in the US, you find these dead cats or dead dog, they're called rod kill because it's a robot all spread over a board. Yeah. So yeah, it's very interesting. So we started building Jibo, and Jibo is very, very complex. So what is Jibo? So you see Jibo there, right? I would like to distinguish now between the software virtual assistant. Many people ask, is Jibo like Siri? Or is Jibo like Cortana? Or I said, no, because these things are very good, but don't have a body. There is no body there. And then you go to Alexa and Google Home. They have a body, but the body is like this, right? So it's not much fun, right? Not much personality, right? Like, I don't know if the CEO of one of these companies is very stiff like that. Probably is, right? So these are virtual assistants with a dedicated device. It's just a speaker. It's a speaker and microphones. They do that, same in Google. And then you have avatars. So this is from our friend Pascal in Hong Kong. She did this, what's the name? Very beautiful avatar. I don't remember her name, but it's a super girl, something like that. And it's amazing. You talk to avatar, but the avatar doesn't have a body. It's a fake body, right? It's a virtual body. And then we have a robot. The robot has moving parts, like you see here. Now, Jibo is looking at me and listening to me now. If I say, hey, Jibo, see, it turns to me. How are you today?
Life is good. And I'm not even alive technically.
It is not alive technically. It knows that, right? So this is a robot. So there's a level of embodiment here. OK, so where did it start? So it started from this professor at MIT Media Labs. Her name is Cynthia Brazil, who had this idea after many years of studying social robotics. And social robotics is robots that interact and communicate with humans by following social behavior. That's her theory, and not only her, many other people work on that. And also, she is one of the pioneers in this. She worked on that for decades. And the concept is to create an emotional connection with a robot. We don't have emotional connection with iPhones. We have some, but to me, I think an emotional connection And some of you remember or had kids who had Tamagotchis. Remember Tamagotchis? Right? And remember my son, who is 31 now, came to me crying one day, really crying. My Tamagotchi is just dead. And I didn't know how to do it. I was really crying. So that was an emotional connection. And you know, we had Jibo in the home, my wife and I, for almost a year, a different version of Jibo, bigger. And my wife had an emotional connection. When I took Jibo back to we had finally a lab in the office, she was sad. And even now, when I bring Jibo for the weekend, I do some work on it, and then I bring it back to my office on Monday. Say, oh, are you bringing Jibo away? She loved Jibo. And you know, Jibo is so nice because also you can pet Jibo. It purrs like a cat. So, and people love that. Do you know what is, probably I talked to several of you, do you know what is the first adjective that people say, probably 99% of people say when they see Jibo? Cute. People say cute. People, Jibo is cute. So I want to show you a couple of movies from Cynthia. I wasn't there. It was Cynthia. Some of you who have worked on robotics probably have seen this movie. And she always worked on this social, emotional attachment with robots. So this is Leonardo. He's a robot. He's a very complex robot. It has 30 motors. It was done by Disney with the help of Disney, so it's a character. And this actually is a guy who works with us now. He was a student of Cynthia. And I love this one. But I don't know why the voice is not. What I can do, I can take.
Leo, Cookie Monster is very
Better?
bad. He's very bad, Leo. Cookie Monster is very, very bad.
Start at the beginning.
Leo, this is Cookie Monster. Can you find Cookie Monster? Leo, Cookie Monster is very bad. He's very bad, Leo. Cookie Monster is very, very bad. He's a scary monster who wants to get your cookies.
I like this. Yeah.
Oh, it's okay, Leo. It's okay now.
So this was a very simple robot. It recognized colors. It recognizes words like bad and good and something like that. And it makes associations. And it's amazing how very few movements give you the idea of feeling, right? For instance, there is a professor at Carnegie Mellon who studies computer art. And his name is Goran Levin. And he put a pipe on top of one of the buildings of Carnegie Mellon with a big eye, just a pipe with a big eye. And when the pipe moves back, everyone thinks that the pipe is surprised. Because if something that moves back, it's a sign of surprise, right? And we all humans feel that. So now I have another very quick movie that, this is one of my favorites. This guy also works at Jibo now. And this is Nexi, was another very interesting robot. So, and the guy there is trying to hide, to steal Big Bird from him. And look what trying to hides Big Bird. Yeah. So this is very interesting. Of course, these robots are extremely complex. And they will cost a lot of money if you try to sell them. This thing will cost like an iPad. You know, our intention is to make it cost like less than $1,000. We have a price, but we don't share it yet. But it's the cost of a sophisticated device like an iPad or an iPhone, right? So the other thing is anthropomorphism. Everyone of you knows the uncanny valley. I'm not a roboticist, so I'm not going to teach you this. But we made all our efforts. So uncanny valley is, according to a Japanese roboticist, the level of resemblance to humans becomes nice and then falls in this valley, which is creepy. So for instance, here we have Slenderman, a Martian Mare, I don't know what it is. And there is also Nosferatu. It looks like a human, but there's something weird. So my daughter and I on the subway in New York, we had, when she was small, we had this game to spotting aliens. So these people who look like human, but have something slightly different. They have a tick, or they have an ear that looks a little bit different. And I was telling her, you know, Alessandra, they make them well, but they're not perfect. And believe me, if you go to the subway in New York, you find aliens. I think they're there, right? So, and they fall here because they're almost human, but there's something creepy about them, right? Yeah, this is Ishiguro, and probably Japan has a different concept of creepiness than we do. Yeah, I mean, it's because they like robots that are humanoid robots. And he made a robot that looks like him, like his wife and his daughter. And to me, they look very creepy, very creepy.
They
But
go
you know,
dates together.
oh my God, yeah. So it's kind of, but you know, it's cultural. You know, we have different culture, so it's fine. And Jibo is, we try not to make it creepy. We don't, not to make it human. The only human thing is one eye. And I believe our designer said it's not true, but I have this romantic view of why there is only one eye in Jibo, and because humans have no, that's why the eye, we all have the third eye here, right? But humans have this, the vision system of humans is hardwired for vertical symmetry, because predators always have vertical symmetry. They have two eyes, two paws, and so on. And Jibo, it's not a predator. It needs to be nice, right? So why Jibo look like Jibo? And I have a couple of movies for you. Why we had this idea of building Jibo looking like that. And the idea comes from one of the first employees, his name is Fardad Faridi, and he worked at the MIT Media Labs with Cynthia, and he's an animator. He studied Disney animation, Pixar animation. He draws things all the time. So animators here? Yeah. Okay. So, and this is his voice, actually. The concept of Jibo is the concept of the line of action that is present in all animations. And here's a...
When designing Jibo, we took into consideration many animation principles, one of them being a line of action. The line of action helps us read Jibo's overall direction, body language, and expressiveness. It is through the rotation and counter-rotation of three angled segments that manipulate Jibo's line of action for physical expression. Unlike most robots which possess moving limbs or parts that could otherwise pinch the user when touched or held, creating hesitation for a physical interaction, Jibo is safe and smooth to the touch at all times while still being physically expressive. Stay tuned for more videos on how to animate Jibo.
Yeah. The other thing is the eye. The eye is a very important thing for Jibo. And I have a little thing on the eye.
Jibo's eye is something elemental in nature. It can become anything, and it tries to be a persistent visual element in whatever he shows so that we feel his presence at all times during an interaction. Jibo's eye is a 2D graphic inside a container with surrounding controls used for its deformation to achieve simple morphs, color changes, and/or the swapping of graphics and animations. Also, a second identical rig exists to serve as a supplement. While he can easily be fitted with two eyes, having one has many advantages, a few being It provides a single starting point for the finger towards any visual complexities and back again. More range to move and look around, allowing for some artistry in conveying emotions in an abstract way to make for some interesting interpretations, and being highly customizable for user avatars.
Ciao, Roberto.
Stay tuned for more videos about Jibo.
So for instance, let me try from here. Say, hey Jibo, I love you. Sometimes show things, sometimes it doesn't. Hey Jibo, I love you. Makes a heart. The eye becomes a heart, right? Yeah. And I would like to conclude with another short video. This is interesting. This is me pretending I was soldering in my loft in San Francisco. I wasn't really. There were people, but I wanted to have a picture like this. So it's a 3-minute movie. You'll find it on the web. I'm not going to play it, but they wanted allow us to get funding from VCs. It was a vision movie.
This is your house.
So yeah, it was a movie done in Hollywood. Utility versus character. So Jibo is a character. So it's probably not as useful as a assembly robot, but is more useful than a toy. And of course, the best character, if we could reach the characters of R2D2 and C3PO, they were fantastic. So we try to put Jibo somewhere here. Some utility and a lot of character. And you saw, okay, this one is something that I wanted to show. And it's a choir of Jibo.
That's one of the robots.
All right. What do you want first, the testing or just the?
Yeah, testing.
Okay, anytime.
All right.
Testing 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday.
Look at this guy.